right, good day everybody. Today's notes video starts off our weather unit, which we break into two smaller units. It's really our weather and climate unit. So we start by looking at all of our atmospheric variables and our atmosphere in the first part of this unit. And then the second mini unit is looking more at tying everything into forecasting weather and climate. So as we go through these notes, make sure that you are filling in your notes as we go and answering the questions. And if you have any questions, bring them with you to class. So we start off looking at what weather is and our layers of the atmosphere. So meteorology is the study of weather. So meteorologists are the people who you see on the news that are forecasting the weather, and they really take time to look at what's happening in the atmosphere, what the weather variables are doing, and try to create an accurate forecast of what we will see in terms of weather. Now, there is a difference between weather and climate. Weather is what's going on right now at a specific time in a specific place. So currently, as I'm recording this video, it is about 55 degrees outside. It is overcast. Who knows what it'll be like when you're actually listening to this video. Climate is taking some of those variables, especially temperature and moisture, and doing a long-term study of the region so that we can say, we have generally cold winters with some snow and very warm summers with decent amounts of rain. We look many, 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 many years to get an accurate idea so that we can have a good idea of what's going on in our region. The major cause of weather is the fact that our atmosphere is heated unevenly. Because we are tilted, not everywhere in the atmosphere is receiving the most direct sunlight. In fact, it only receives it equally on the equinoxes. But because of our tilt, places that are directly facing the sun, like the tropics, tend to be the warmest, and as we move to the poles, it's less intense. So this creates an imbalance in the atmosphere, and it works to try to send the heat to the cold areas and the cold to the hot areas. All right, over the course of this unit, we are going to be looking at temperature, moisture, specifically relative humidity and dew point, clouds and precipitation, air pressure, and wind. And then we'll tie all of them into actual forecasting in the next part of this unit, which is the second mini unit. So where does our weather occur? Well, it's happening up in the atmosphere. And when we're in class, we'll see this video together. So the atmosphere is the envelope of air, the sphere of gases that surrounds the planets. And if you look at the pie chart that you have in your notes, and that's up on the screen right now, in purple, the most abundant gas is nitrogen, followed not very closely, but the next of most abundant is oxygen. And that ties into what we looked at already with our reference table. And previously, you should have written that the troposphere is the atmosphere. And if you haven't on your reference table, you might just want to make a little arrow coming off and write atmosphere. So whenever it's talking about percentage of gases in the atmosphere, you look at the troposphere. Our early atmosphere formed as a result of volcanoes, pretty much. The volcanoes, when they erupt, send gases along with ash up into the atmosphere, and those gases started to build up and build up and build up. And early Earth's atmosphere, very different from what we have right now. It was a lot of carbon dioxide, sulfur dioxide, water vapor, and still nitrogen. But there were more amounts of the carbon dioxide and sulfur dioxide, tiny amounts of the water vapor. And eventually, organisms developed that could start going through photosynthesis And by going through photosynthesis, they're taking the carbon dioxide in from the atmosphere, going through all those processes to get itself food, and a byproduct was oxygen. And so oxygen started to build up. So early atmosphere, much different from our atmosphere today. So we break our atmosphere down into 4 layers, and those are based on the fact that the temperature kind of changes direction as we move up. It's not straight up and down. It is going back and forth, and we're going to talk about page 14 more the next time I see you. And what you just need to know for right now is that our 4 main layers, working our way from the bottom, is the troposphere. That's the layer of the Earth of the atmosphere that we live in. Above that is the stratosphere. Above that is the mesosphere. And then the outermost part that extends into space is the thermosphere. Now, very important gas that we find in a layer of our atmosphere is ozone. It is actually 3 oxygen molecules. And it is important because it prevents ultraviolet radiation from the sun to reach the Earth's surface. So it essentially is a big thing of sunscreen acting for us. And if we didn't have that, it would be a lot more hazardous outside. We really wouldn't be able to wear short sleeves and shorts. Plants probably wouldn't be growing. So it'd be a very different planet than what we're used to if we didn't have ozone. So ozone is found between 12 kilometers and 50 kilometers up in the atmosphere, and the layer that we find ozone is the stratosphere. Please remember that. That is going to be an important piece of information that you keep track of. Now, in between the layers of the atmosphere, we have these pauses. We have a tropopause, a stratopause, and a mesopause. What are the pauses? They are just the boundaries between the different layers of the atmosphere. And we note them because this is where we have a change in temperature. Once air hits that boundary level, the temperature immediately changes to the opposite. So as we're moving up in the troposphere, temperature decreases. We hit the tropopause, which is in between the troposphere and the stratosphere. And once we hit the tropopause, temperatures start to increase. They start to warm up. So every time you hit a pause, which is just a boundary, temperature changes. If it's been increasing, it'll start to decrease. If the temperature has been decreasing, it will start to increase. And so the layer of the atmosphere that we see the most weather, that would be the troposphere. And the reason for this is the layer that has the most water vapor. And you have this fun diagram in your notes, which I will talk about a little bit more the next time I see you. So make sure you answer the final questions, and you've submitted it and you've turned it in on Edpuzzle, and we'll talk to you later.